So you may have just seen the video on independent and dependent events. Generally, you can tell if if events are independent just based off of the context of the events, but sometimes you don't know what the events are. Sometimes you just have their probability. So when you just have the probability, we can use this formula right here to find out whether events are independent. So if A and B are independent events, then the probability of A and B occurring is the probability of A times the probability of B. So let's take this example. An airport employee collects data on 180 random flights that arrive at the airport. The data is shown in the two-way table. Let event A be the event that a flight arrives late. Let event B be the event that a flight is an international flight. Are A and B independent? So as we're doing this problem, we want to keep in mind that this is the information that we need to find out. We want to know that the probability of A and B is equal to the probability of A times the probability of B. So the probability of A, let's look at that. Event A is arriving late. So how many arrive late? Let's look at the row. And 18 arrive late. So the probability of something arriving late is 18 out of 180, which is 1/10. Okay? Keep in mind your denominator has to be your total. Okay? And our total is 180. So let's look at the probability of B. And B is that a flight is international. So let's look at the international row, and that's 60. So that's 60 out of 180, which is equal to 1/3. All right. Now, the probability of A and B is very easy when you have a chart. All you do is you look at their overlap. So you can see that they overlap at 6. 6 of the late arrival flights are international. So that's 6 out of 180, which is 1 out of 30. Oops. Okay. So now the last thing that we need to find out is what the probability of A times the probability of B is. So we take the probability of A, which is 1/10. We multiply it times the probability of B, which is 1/3. And so remember, with fractions, you multiply straight across. So 1 times 1 is 1, and 10 times 3 is 30. So if you notice, you see that the probability of A times B is equal to 1 over 30, and the probability of A and B is equal to 1/30. We're looking at this. So since they're equal, they are independent. So yes, they are independent. That's your final answer. So you would need to show your work to be able to find out whether they're independent or not. For this one, I think it's a little bit easier. You can't really see the context of the problem, but you can easily apply this rule. So keep in mind that and is the same thing as intersection, okay? So, since the probability of A and B is the probability of A times B, we're going to put it in context. So we want to find out if the probability of M times the probability of N is equal to the probability of M and N, or the intersection of M and N, same thing. So the probability of M times N, we're going to look at our M, which is 0.4, and we're going to multiply it times our N, which is 0.22. And when you do that, you get 0.088. Now we need to see the intersection. This is actually taken from the Common Core exam. So we need to look at the intersection, which is 0.12. Since the intersection is not equal to this number, it is not independent. Okay, so again, they are not independent because the probability of m and n is not equal to the probability of m times the probability of n. So that's a problem. So it's not independent. Thanks for watching.